So,
Yeah, hello. Hi, Adev.
yeah, hi, sir.
Yeah, hi. How are you?
Fine, sir.
Okay.
Fine.
So did you play around with that afterwards?
Yeah, afterwards I did play around. I checked the at that same site, right? The one where the Google the machine training one, right?
Yeah.
Yes, I did play around with that, and then I check. I added some more classes and all. It was able to identify and check. And then I changed the number of epochs also. The accuracy didn't change much though. I reduced it by around 10. So pretty. I didn't have much of an effect though.
Okay. So today we will talk about that. See, no, it's a black box as is. See, somebody tells me to drive a car. I go and just take a driving session, just rotating the wheel and all. I'm able to do it, right? I
Yeah.
get a hang of it, how much to turn the wheel and how much to give acceleration. So it's very few new nuances for driving a car. I think you have not done it. When you will come to that place, you will see it's not a difficult problem. Okay, it takes
Okay.
1 or 2 months
Fine.
to learn a car. That's all. And then over a period of time you become expert. You don't have to even look anywhere. In the starting, probably you'll have to look many places. I used to look at the my left side also, and the right side also, and the back side also. And then over a period of time you get a hang of it. I don't have to even look anywhere. It's automatically doing. I have learned the art of it, right? Similarly, for you to learn AI, how exactly to tune the epochs model, what is the learning rate, and what is the transfer, what is the other things, right? You will get it slowly. Hmm? As much you
Okay, sir.
practice, you will get a hang of it. But then we will also need to look internals. I'm not going to tell you right now, but I'm going to give you some more things about AI, and then we will go back to that and look into that, and
Sure.
I'll tell you how exactly accuracy, what is accuracy, and what is that internals. Apart from that, we will look at your data set also today.
Fine, sir. Okay.
So I'm going to present you one slide. Okay, so Adib, can you see my slide?
Yes, sir. I can see a slide.
Okay, so we knew that coming to artificial intelligence is a bigger umbrella under which we have machine learning and deep learning,
Yes.
and data science is basically using these technologies for doing the science with the data. So you must have heard data scientist nowadays, isn't it?
Yeah, yeah.
And data, so a lot of things are done. So when you say that analytics, what we were talking about, augmented analytics, that is nothing but using data. You are going to do lot of things, right? Understanding business and etc etc. But then if you really look at it, it is just using a portion of their artificial intelligence to do it. But otherwise there are so many other things which needs to be done, which is software engineering as usual.
Okay.
So that's what data science is all about. It just uses a small part of data, artificial intelligence, to do certain tasks which mimics a human being. That's it.
Okay.
Now coming to so there is a pipeline. How exactly it happens? So can you see there is on the left hand side there is a data ingestion is there.
Yes.
That is what your data is. Whatever you looked at data set, right? That is your data.
hmm
Okay, and so data ingestion means you get the data. So remember, do you think you have only 5,000 data? It's going to work? No, it might not work. There are so many cases in eye problems, right? There are so many things which keeps developing over a period of time. Human beings keeps discovering things, newer and newer things, right?
Yeah, yeah.
A
You have to
lot of
update the database then.
yeah, and that is what is
Yeah.
called data lake. That's called data
Okay.
lake. So that is a database where you update it, and it's a huge database, right? Huge amount of data would be stored there basically. That's called big data basically.
Okay.
And this was a training cluster where you trained it. You saw that, no? After you gave the
Yes, yes.
data, you were training it. Whatever your photos were there, and then photo of your background as well as that. That was a training
Yeah.
cluster. Fine. You could even deploy it, which I did not show you today. I'll show you. You can deploy your model. You can use your model, and you can actually deploy it in a website, and then you can actually show it to your friends.
So
So
this is the deep learning pipeline, right? It's sort of like
AI
the
pipeline, it's a AI pipeline.
AI deep. Okay, fine.
Irrespective whether it's machine learning, see, AI is a bigger umbrella. Which, so what happened, machine learning was the primitive one, and over a period of deep learning also came in. And I'll tell you what is the difference between machine learning and deep learning as well. So not everywhere you can use deep learning.
Okay.
You cannot. So the deployment part, what is the deployment part basically? So now suppose you right now, see, suppose you in fact did it something on your own, right? But then something which is useful to the outside world would be if they can distinguish between, let's say, 10 varieties of vegetables, let's say, okay, and then you want to make a game out of it. So you train your model with 10 different types of vegetables, like ladyfinger, brinjal, and whatnot, okay, 10 different. And then once you train your thing model, you would like it that somebody, like some kid out there, you want to commercialize it, right? You want some kid out there to learn, and the parents would buy that app, or let's say it's a free app itself, and they will take the app, and they will the kid will show to the camera ladyfinger, and it'll say it's a ladyfinger. He will show probably a cucumber, and it'll say cucumber, right? So you would have
Yes.
trained your model with certain
Yes.
things. Probably if you want to commercialize, you should be training it with probably 200 vegetables. Better, right?
Okay.
uh,
Yeah.
but whatever it is, but that is the deployment part. If you deploy it, how do you deploy it, where do you deploy it, then how do you access it so that somebody can use it? Because till now it is there in your computer, right? What is the use of it? You can only learn, that's it.
Yes.
You want to make money out of it, then, or let's say somebody is, it is useful for somebody, you need to deploy it. So what is the deployment all over? Deployment is a server where your model goes and sits. And what is a server, by the way? If you see what is a server, if Gmail is accessing one server, right? So you are the
Yeah.
client of a Gmail, and your all the emails which are there, is it's in the server, Gmail server, right? Similarly, your model, which is
Yes.
trained with 100 vegetables, let's say, which can identify which vegetable is what, has to be deployed in a server. So
Okay.
now,
Okay. So basically, sir, the deployment is where your model is being deployed in the server, right? You're creating a server and you're deploying the model.
yes, at the end, that's what you want. No, you, whatever your eye detection you want to do, you would like to commercialize it. Why? You made it. Let's commercialize it. What's wrong in that? Or let's say
Okay.
somebody should be able to use it. They cannot connect to your computer and use it, isn't it? Because the model is there in your computer. Till now, I have been talking about model. I think, what is model, by the way?
The model will be the like mimicking the real life situation then, like
Oh,
mimicking, and the model will be like creating a prototype.
yeah. So model is the one which is a brain, right? Which you are training.
Yeah. Yeah.
So in our case, model is our brain which learns, in fact, right? So over a period of time, we are learning. We were given so many samples. We learn, right? And after some
Mhm.
time, somebody wants to use our service. For example, I have been learning on training, and I have been learning on how to teach different types of subjects, right? So now my mind is a model for a particular type of trainings which I can give, right?
Okay.
But I did training. By how did I do a training? I went ahead and I gave training to a lot of people. I have so many samples I saw. I trained you. I trained a lot of people
Yeah.
like
Yeah.
that, right? Probably 50 people I taught. Those were
Okay.
nothing but the training to my mind, basically, right? My mind kept learning, kept learning, kept learning, kept improving.
Mhm.
Now that is the model. My mind now
Okay.
is a model. So your mind is also a model for certain learnings. What you have, what are services you can give.
Mhm. And so then for data ingest, so that will be you're taking the data then, right? And then data prep, you're collecting all the data into a data lake or the database.
Exactly. Data preparation is data lake. You're going to send data ingestion. You keep taking the data. For example, in your case, suppose you have eye thing, so you would like to take the data from as many eye hospital as possible, because that is what your model depends on. You'll have to
Okay.
tie up with those people or whatever. I'm just telling you one example. Now that goes with anything else also, right? Without the data, machine AI is nothing. Nothing.
Yeah. Yeah.
So you need variations in data. As I told you, as much data is there, that many cases you can solve, and that much more like accuracy you can have, because machine learns from as many data as possible. So, for example, for me as a trainer, if I can teach 1,000 people, I am a better trainer. And similarly goes with pilots also. Have you heard of pilots,
Yeah.
that how many hours of flight they have done? So that is again,
Yeah. Yeah.
so the training is all about, and then experience. The more the experienced person is, the more valuable he is,
Hmm.
right? So this data has to keep
Okay.
coming. So you have 5,000 data, agreed, but don't think that that's it. No, it has to keep coming if you want to commercialize it afterwards.
Okay.
and
Fine. Fine.
and so that is a continuous process.
Fine.
And data preparation, that is where you store it and then you train it. New data comes, you still train it.
Okay.
And then could you see in the training set, there is set 1, set 2, set 3, and that set, the test set is there. So the point is, you had
Yes.
5,000 data of I, whatever you have right now. You cannot use all the 5,000 for training, because if you do for training 5,000, how will you test it? Because machine has to be given a surprise of something which is not seen by it. If it has seen the data, it knows it. It knows that this is cataract or this is diabetes. It knows it. But then you, and the real time something data which comes to you is not a data which it would have seen anyways, right? And it has to predict whether it is a cataract or it is a diabetes or it is a
Yeah.
hypertension, right? So that's why out of 5,000, what you will do usually,
So the one test set
yeah,
will be there, right?
test set is there.
One test will be there to check the
Yes,
accuracy, right?
yes,
What you're saying.
absolutely. That would be
Okay.
a real time, surprise. Come on, that's like something like test. Okay, what happens in your school is they teach you everything, and then they have taught you everything, and the test, there'll be test. Okay, you have a book where you have read everything, but then that's your training part. Your teacher have taught you, but then test is always a surprise. They will not tell you all the questions. You go and learn from the book, and the test comes, which is a surprise to you, right? It is not a known question to you, right? So
Mhm. Yeah.
tests are always like that only. If you go to Olympiad also somewhere else, right? There's an unknown question which would come in. The pattern, you might see certain questions from past and something, but still there'll be unknown questions, right? And that's how you test a training model. But in actual real life, that's how it would be, right? You have only 5,000 data. Do you know how many people are there in this world? There are about billions, right? And different patterns of eyes are there, different patterns of
Mhm. That's true.
disease, the same thing, hypertension or diabetes, different pattern would be there in the eyes for telling whether it's a cataract or whether it's a diabetes, or right.
Okay. So what I can do is probably I can collect some more data. I can look for more data sets and I can maybe combine them into like a data lake, maybe like you're saying, and
Yes.
prepare the data and store all the data maybe. Or also what I could do is when we're creating the project, also at the end, right, we also have to explain the strengths and limitations. Maybe for that I can explain in the future what I can do to improve the project. Also maybe I can talk about how the large amount of data will create a greater accuracy. So I can go about collecting more data.
Absolutely, I think when you tell them, they will be impressed by that, in fact, right? And I mean, you are going to tell them whole pipeline of it. And that's
Yeah, yeah.
true. But then you see, out
Mhm.
of 5,000, you can only train with, let's say, usually the percentage is like this: 80% of the data, whatever data you have, you'll use that for training, and the 20% you'll use for testing. So out of 5,000, 4,000 you will use for training, and 1,000 you will use for
Okay,
testing. And in the testing phase, you will take out the labels
fine.
and then test it, and then you will compare whether it is working properly or not. It's like exam only, no? Doctor, they will be shown so many samples of the eye doctor. If you say now you are creating eye doctor here, eye doctor would be shown so many things in the hospital. In the exam time, they'll be shown some certain samples which they have not seen, and they'll have to tell.
Yeah, yeah.
Right.
And then so then finally searching archive data to create the public or private. Yeah, to either make it public or private. I thought that when you're talking about that, I thought it'll come under when you deploy when you're deploying it. Then I thought that will itself make it public, right?
Right. So cloud. So you know, to archive data, public or private, it's like up to you, right? Certain companies would like you to have it private, right? And so your data, you don't want to expose it to others. Some people like make it public. The one which you have is public. That's why those I data is there with you, right? And then this is
Okay.
also talk. This is from not only from the data set point of view. This is also from the model point of view. So Adip, try to understand that model which you created now, right? You don't know what is inside it. But given an input, it will
Hmm.
predict whether it's Atif, whether it's a background, or
Okay,
whether it's a mobile, right? Now, take that model, give it to
fine.
anybody, they will give the input, and they will get the results. So that is what also even the model which is trained
Okay,
model could
fine,
be made
fine.
public or private. It's up to you. If you make it private, that means you will put it in a server and you will take money from
Sure.
somebody to access it and use the services. If you make it public, somebody can take it. And what they will do, I'll tell you what they will do. Let's say, for example, you made it for this I
Mhm.
thing, right? So you had 5,000 data, you trained it and you put it public, or let's say you put it in private. You can sell it to somebody at the end, or you can put it public. So now they take it. Of course, they'll have to give a credit to that to you that they have taken from you. But now they have, apart from 5,000 data, they have another 10,000 data of it. Now they will train your model on the top of whatever you have trained. So now your model becomes much more stronger, basically.
Fine. Okay.
You know what is this edge? What we are talking about edge? There's an edge. Edge. What we are talking about?
Yes, it's I think classifying the
Yeah, edge data.
edge
What is edge?
data. Yeah, I think it's classified
Edge
edge
is
for
nothing but
cloud,
from
right?
the
Yeah. I'm guessing the
yeah.
edge data will be like it's a small. I think it'll be the initial data, right? And then it's close to the like you were talking about the experience and all that stuff.
edge,
It'll be close
edge
to
data
that,
is
right?
coming from the source, right? The sources would be basically, the hospitals, right? In
Be
your
close.
case, I think, right? The local hospitals. That is edge. Edge is nothing but getting it from the edge. Edge
Yeah.
means edge, really edge, from where it is coming, right? So, but you will realize, the
Fine.
way the AI is, why people are talking about AI, because now you can store a lot of data, first of all, and then now edge computing is coming into picture. What is edge? Is nothing but edges, watches, mobiles, your laptop, they are edge. That is where the data is generated. For example, if I have a watch, right, health watch, that is edge. That is exactly getting the data from the real time, getting the data from the source where it is supposed to be. So my data of heart rate, heartbeat, everything is going right there.
Okay.
So these are all edge. So now a lot of edge
Yeah,
devices
yeah.
are coming, and that's where the IoT. I don't know whether you know about IoT or not. Internet of Things. Okay, so Internet of Things are like, these are the things. These devices which I was talking to you. These are the things. The one which is on my hand, right? So these are the things which are
Okay.
sending the data on the real time basis to cloud. Why cloud? Because cloud, Google Cloud or Amazon Cloud are massive, massive. Can you imagine? Google has so many Gmails, and every Gmail has 15 GB of data. I don't know whether you know about it or not. Every Gmail has 15 GB of data.
Yeah, yeah. Okay. No, I didn't know that. I didn't know that specific. Yeah, but okay, I didn't know that specific though. Yeah, but I do know that they have like, only a certain
Yeah.
amount of
So
data
now,
storage.
the point is, there are billions of users of Google, and that is amount of storage which they can provision, because that's a big corporate, right? Google is a $500 billion company, right? So they have a lot of muscle power to create a data set. A normal person
Fair.
cannot do it. That is why we are talking about cloud. If you want to use AI, you have to go to cloud. Otherwise, you don't
Okay.
have the muscle power of the hardwares to buy and train, because AI requires data. It requires data. It requires
Okay.
GPUs,
Fine.
massive amount of GPUs. Now you will see that
Fine.
you had only 200 images of yours, and then another background was 200. Still, your system was getting slow. My system was getting slow. I don't know what your system was getting slow or not. Uh, you have three data sets,
Mhm. Yeah, yeah. It's yeah, yeah.
but cloud has massive amount of hardware which you can use. And that is why we talk about cloud. If you have the muscle power to have
Okay.
the money to have the hardware, then use your own thing. There's no doubt about it. But usually the best practice is go to cloud and start using cloud resources. Why? Because if you want more resources, you can get that in cloud. So cloud is something like this. Cloud is a rental basis. Cloud says that I will give you storage in rental basis. I will give you the CPU power and GPU power in rental basis, and then I have a power of elasticity. If you want today, you want 5 GB of storage. Okay, I'll give you 5 GB of storage. You have to pay me X dollar per day, and tomorrow, if you want lesser, two GB of hard disk. Okay, take it 2 GB, and then you have to pay lesser amount. Similarly, that goes with GPU and CPUs as well. and it has the elasticity. Elasticity means it can
Fine. Okay.
expand to probably 500 GB, 1 terabyte, 2 terabyte of storage, or it can expand to 500 CPUs, 600 CPUs, or it can come down to one CPU. So on a rental basis, they charge. That's what is cloud. Okay,
Okay.
coming to so we saw, see the edge. So look at, so many edge devices are there. So many dots. Can you see these are edge devices? Watches. For in your cases, it would be clinics. So many clinics of eye
Yeah,
hospital,
yeah.
right? So they are edge. Data is coming in, right? So now global ingestion through throughput oriented, globally accessible, capacity tier. So now these becomes a bit hi-fi for you. So don't look into inside it. So I'm just going to tell you from the data comes in. So classification and metadata tagging, high volume index and auto tagging zone. Forget about this. It goes to Hadoop. So that is a data lake, right? So there's certain processing which is happening and auto tagging is happening, high volume index and auto tagging. So the label, whatever is called label, right? That is called as tagging. And goes to a
Okay, fine.
Hadoop system, which is your big data. Forget about this. What it is, you're storing a massive amount of data there. And then preparation, training, inference. Okay. Now, what is inference, right? You know what preparation, you know what training. What is inference? Inference is the once you trained your model, you did an inference, right? You came in front of it, it told Adil. You went outside, background was there,
Yeah,
it showed background. That is inference.
yeah.
Okay,
Okay.
high throughput. Okay, that's fine. And archive, ETL, forget about this. So this is like going too much, might go too much for you. So, but you can see on the top side this edge, ingestion, classify by transform, analyze by train, and insights.
So you're first, they're taking the edge data, you're taking and then you're ingesting it and you're creating it into storage and all, and then after that, for classifying and transforming it, that'll also be part of preparing, right? Data prep. So that's why you're classifying and you're tagging it. So to create,
Just hold on. This classify
yeah,
transform is quite important. So what happens is like you
okay,
have a label already, right? If you didn't have a label, then you might have to do certain actions to do it. We will see how exactly that is done, because you right now have label with 5,000, but transformation has to be done. Still, the whatever images you have, do you think that is fine? Will it work out? I mean, you cannot say that, right? Will it work out or not, right? You might
yeah,
have to
yeah,
transform. What does the transformation means? Transformation means probably the images what you have, they might be of different dimensions. What is the dimension? 220 into 340 pixel, one image might be there. Other image might be 300 into 400 pixel. But you need to put it into a standard format. That is called transform. You'll have to put it in a standard format, which is probably 250 into 350 pixel. Do you understand the image is having what the TV? What you see? Height. That's full HD. Have you heard of full HD in TV?
yeah, yeah.
What is full HD? It is, if you really look at the specification, it says 1082 into 1984 pixels. Have you seen that? Have you?
Yes, yes, I've seen that. I've seen that.
That is nothing but that's your height is 1080 and the width is
Mhm.
1984. That is nothing
Okay,
but that's the size of the image, because that's a TV. The TV can show that much size of the image. The bigger the that's the size. No, I'm sorry. That's not, TV could be bigger and smaller also. that's
yeah,
the
yeah.
that's the resolution of your image. मतलब how many pixels are there in the image. So that part we will come, because see, that's a part of computer vision, right? So I will take you through that slowly. I will take you through that, how the image looks like, how the image processing is done, and how we take it to the thing. That will be a separate topic altogether. We'll come to it. Okay. For that, we will be using computer vision, Python library.
Okay,
So you need to do certain processing on your images, transform, change
hmm,
the image to certain thing. Either you increase the brightness or decrease the brightness of the image, or you take out certain noise from the image, like noise or something background where it is not proper. You do some sort of filtering you need to do before sending it for training.
okay, fine.
And insight is nothing but the inference. So you get an insight out of it, right? So what is the insight? Whether it is diabetes or whether it is hypertension, right? Or whether it is cataract, that is the insight.
Okay, so the insight will be is that okay after transforming then.
After transforming them, you analyze and train. So analyze is also there. That's a big part of it, right? It's a big part. And if you really look at AI thing, right, these becomes a big part. Can you see it from here? Edge, ingestion, classify by transform, analyze, huge part. People don't realize that. They think only training is the only thing. No, training is just the 5% of it. But before this, getting the data and all, that's a big thing. Yesterday we were talking about, right? So if you wanted to learn something, you go for take a book. Do you understand the amount of time that person, the author, would have taken the data from somewhere and then collated the data, presented in a proper, beautiful format, put the graphs out there, proofreading would have been done, errors would have been taken out, and that is the data what we are talking about. So if you really look at it, that is what data collection is. I'm just giving you one parallel example. Like if you wanted to learn something, data is so important. Data cleaning is so important. Data has to be a beautiful format. If data is not good, what how much amount you train, you're going to get bad outputs. So consider
Fine.
that you go and read a bad book, you will not learn properly. Rather, you
Okay.
go and buy a book which is good presented and which you enjoy learning. Probably you will be trained better in that. You'll have better knowledge.
Fine.
Now you are telling you have 5,000 I thing. So somebody has collected data for you, but are you sure that data is fine? You still need to analyze it. You still need to transform
Yes,
it.
yes,
Transform
definitely,
analyze is still
definitely.
remaining. Classification they have done for the images, but this is these two parts are still remaining. They have done this part: edge, ingestion, classify. This part is already done.
Okay.
Now, uh, okay. Now go to the another part. So now we are talking about edge, initial point of data collection and aggregation. The edge devices could be, let's say, mobile, it could be aeroplane, it could be a car, it could be any industries, right? It could be computer. Could you see here?
Yes, yes.
And then data goes in and the core dedicated hardware by private cloud deployments. Forget about private and see, just think about it's in cloud or it's a processing unit, that's all. It goes in, then whatever you saw on the top, hosted as a service solution, long-term data archival. So now big business are coming for just data collection. Somebody who can collect the data. Probably you got it free, right? This data, but you can understand there are people now who is collecting data and they're selling it. Now that's because at the end, if you want to come with a commercial application of doing something useful, you need data. So data is a gold. There's a statement going in right now. Data is the new gold, right? And so
Yes.
data collection and then having the data in a proper format and storing it somewhere so somebody can use it is the thing. Either you can be public or it could be private. Again, you
Fine.
store it in the cloud. So if you really see Kaggle, the data what you have, Kaggle is a cloud, you know. Kaggle is a cloud from Google. Okay, let's come to machine learning versus deep learning. So Adip, this is going fine or you're it's like it's difficult for you?
No, no, it's fine, sir. It's okay. So maybe, yeah, no, I think it's fine. Like just a few extra words, but yeah, I think the basic crux of it, at least I'm understanding, like what all you need to do in order to train and then to do machine learning and all that. And I think machine learning and deep learning also, I think we discussed in the previous class also.
Yeah. So now you have an input. So whatever input in this case, it's telling car, but in your case, it is like input is your the what, images, right, of eye. If you are using machine learning, you need to do feature extraction. So what is a feature extraction all about?
Okay.
So now new term coming in, right? Features. What are the features basically? Uh, Yesterday when you in fact did like Adev versus background versus the mobile, right? If you really look, they were the all images, right? And at the end, images had certain pattern. Your face, Adif, in an image has a certain pattern. Mobile has a certain pattern, and the background has a certain pattern. The way it looks, right? Those are called as features.
Okay.
I will go a bit deeper into image, what the feature means, slowly to you. But let us say now let's come to a very easy example. Let us say you need to say what is the weight of a person from the height.
Mhm.
Okay, so what you need to tell, what is the output? Weight. And what is the input? Height. Am I right?
Yeah.
So in this case, feature is height.
Okay.
What is the feature? Height. This is one
Fine.
dimensional data. This is one dimensional. Now we will see in images how many dimensions are there, how many features would be there. We will see that. But if I want to predict the weight of a person from the height, then given a height is the feature. So from height, I can tell what is the weight of the person, and it's a simple linear equation. You have you learned linear equations as of now?
Yes, yes, yes.
So y equal to f of x, and in this case, y is equal to 1.5 times. Let's say what is the height of a person? Let's say in centimeters. Okay,
Okay.
180 centimeter person usually has a weight of 80. Okay,
Mm-hmm.
180 centimeter has 80. So
80
probably
watts, like, okay.
80
Because
kg,
I pick up a unit.
80 kg, 80 kgs,
Fine.
right? So if you really do the maths behind it, and then if I have another data which says 173 centimeter person has a weight of 70 kg. Now
Okay.
do one thing, divide 170, okay, 70 divided by 170 and 80 divided by 180. What is that number coming to? Can you tell me what is that number coming to? First divide 70 divided by 170, and the other one is 80 divided by 180.
Okay. Then 80 divided by 180 then.
Yeah,
It is, it's slightly different, but coming around zero point 0.4.
both are point 0.4.
Yeah, 70 by divided by 170, and then 80 divided by 180, right? It's I mean, see, 80 by 180 is 0.44 recurring. 70 divided by 170 is, it's an irrational number, 0.41176. It's not the same number, but around zero point 0.4.
Now I'm going to tell you the model. If you were supposed to predict the weight of a person from the height, I will tell you the what model is. So first model we are going to create now, and I'll tell you what model means. Till now you were thinking, no, what is this fancy thing called model, right? How do what is how does it looks like, right?
Yeah, yeah. Okay. And so you were saying, that so what's the main difference between machine learning and deep learning then? So the machine learning, see, it can be trained, like, and it can be trained and learn, it can learn without external programming, right? It can mimic human behavior. The deep learning will be extracting patterns, right, from the features of the input.
Very good. Perfect. So that's what deep learning does. And in fact, you don't have to really extract the features. But in machine learning, there's extra hard work of extracting the features. That's what it is. In fact, there's a hard work in machine learning. There is a less of hard work in deep learning. That day, whatever you did was a deep learning. In fact, that identifying whether it's Adev or mobile or the background was a deep learning. You
Okay.
did not do anything, right? Nothing.
Yeah, yeah. So deep learning. The feature recognition is involved itself in
It is
the
not.
classification, right?
It is involved automatically. Yes, yes, it is involved automatically.
Mhm.
But having said
Fine.
that, you don't know how deep learning works, so it's a mystery. Nobody knows how exactly it works. Inside how exactly it cannot quantify that. It if this is there, then this will happen. If this is there, then this will happen. It cannot quantify that. So when you say banking regulations, insurance regulations, government regulations, where they tell that okay, how exactly your algorithm is working, in that case you cannot use deep learning. In fact, in banking you cannot use deep learning. You have to use machine learning. You have no other option because machine learning can quantify, yeah, my features are these, and based on these features this is my output coming. But in your
Fine.
case, that is a deep learning problem straight away.
Okay.
But certainly you need to do some sort of a transformation of your data before giving it to the model. So let's come to a very simple model. And the problem what we have here is I need to find the height from weight. So my function y is equal to f of x is what I have it.
In this case, the h is equal to, in this case, the h is equal to f of w then, right?
Yeah. So f of w, very good, super. So in this case, h is equal to f of w is there, and model is nothing but this function. This is all deep learning, machine learning is all about.
Okay.
This is it. It's not
Fine.
difficult science at all.
So you're treating it, then you're just, the model is just treating the relationship between the input and the output.
Perfect. Very good.
Okay.
It's becoming very easy to teach you. Yeah,
Fine.
I'll tell you. I've taught many people there. It's difficult to teach. This is so good.
Because the thing is, actually, we just did functions in ninth grade. That's a lot of this we're talking about. So,
Okay. Now let's come to whatever we did. Okay, sorry. So this is the model is the f of thing. Here the feature is only one feature. Output is height, and the feature is only one feature, which is a weight. So now what we did is we took two samples. Two samples. I'm telling.
okay.
I'm sorry, this handwriting is not going very good. I have to buy this pen, digital pen. So now after two samples, and my two samples were my wait. Oh, sorry. I think what I did was wrong. No, my thing. We are supposed to find the weight given the height, right?
Yeah, yeah.
We need to find the weight given the height in centimeters. So my two samples are my height is 170 centimeter. My weight is 70 kgs. So
Okay.
so this is centimeters. This is a kg. My height is these are two samples we graded, 180 and weight is 80. And from the calculation we got it is 0.44. Let's say 0.41 and 0.44. So we divide it. We take the average of it. 0.42 we get. Let's say. Okay.
Okay, fine.
So we got 0.42. So now I get one more parameter which is not labeled. In this case, it was labeled. So what was labeled? 70 was labeled and 80 was labeled, isn't it? So
Yeah,
now I get one parameter 160. Now I have to predict the weight of it. So what I will do is, because I have trained my model and my model got that weight equal to 0.42. I'm sorry. It's becoming interesting.
yeah, no, yeah. So that constant is then it's trained, right? The machine has
Yeah,
learned
so
that
machine
constant.
has learned that equation is w and h, the relationship is uh, 0.42 into what is it, h, right? uh, okay. Okay, 0.42 into wait. So it is 0.42 h. Okay, so now given 160, my weight would be nothing but 0.42 into 160. Can you tell me what is the output of 0.42 into 160?
Yeah, the answer is 67.2. So that is, see, the pattern we're seeing, it should have been 60, but it's coming to 67.2.
67.2. 0.42 into 160 is okay. How much is coming? 64.
Yeah, 0.42 times, yeah, 0.42 times 160.
Yeah, how much is it? Oh,
That's 67.2. Because actually there's no for 70 by 170 and then 80 divided by 180. For 80 by 180 constant is 0.44. For 70 by 170, then the value there is 0.42. So it's not
0.42, right?
not exactly a constant, like.
Okay, so whatever it is, there is a problem here. So usually 160 centimeter people would have a, what is 160 centimeter? Is it 5 point? It is around 5.5, right? Okay, so 160 centimeter usual height would be around 60,
Yeah, yeah,
64 or something like that. So we are predicting to be around 67, right? 67.2.
yeah, yeah.
See here, so we have 160, usually the weight is 57.6, and for 170 the weight is 67.6, and for 180 the weight is 77.5. So if we were let's say 77, let's do this thing, 77.5 divided by 180. Let me do it.
Wait, so this is for both. This is for male and female. It is given because there
Okay,
is
yeah,
two
yeah. So this for
columns.
male and female. So let's say for male it is
Yeah.
85 85, and for 170 it is 73.9, and for 160 it is 61.6, right? So we did the same
Mhm.
thing, approximately, okay, 73. So, but you get the crux of it, right? Get the crux of it. What we are trying to do is, model is nothing but the equation. And look at this. This equation now had only
Okay.
one variable,
But
and the variable was h, which is a height.
yes.
Whole of machine learning and deep learning,
So now this is a very simple model then, right? Because only one condition is there.
only one
Only
condition.
one variable is there.
And try to understand this. This was not hard coded. So the point is, the usually what we'll do is we'll have a sample of 200 samples would be there of different people. Means about, let's say, not 200, it should be around 2000 to 20,000 samples would be there. And after we train it, this number, whatever machine comes to, this is like now we did with only two samples, right? And it is not accurate. Can you see it is not predicting properly? It is giving 67.2, but
Yeah, yeah.
actually it should have been
Mhm.
for 160 it is coming 61.6. So we are deviating by 5 kgs, but at least still it is okay, good. Plus minus 10%, plus 10% of 61 is 61 plus 6 is 67. So at least 10% accuracy, 10% deviation is there, which is good prediction, right?
Yeah, yeah.
But having said that, if we had trained with 2000 such samples, whatever formula would have come to, probably zero point 0.4 or 0.36 or whatever it would have come, right? We would have predicted it. And try to understand that you never went there and hard coded this formula. This formula was learned by the machine at the end of it.
Yeah, yeah. So that's the difference. That's with machine learning. See, because we are not finding that relationship. The machine is finding the relationship,
Machine is finding
right?
the relationships, yes, absolutely.
Yeah.
And that is what, yeah, beauty, super. So machine is finding that
Mhm.
relationship here, and this is what we got. And this is a simplistic model which we saw, and this is called as linear regression model. So welcome to the first model, that is called as linear regression. As you say, linear
Okay.
equation, linear regression. So there's some problem happening with my mouse right now, it is not able to do it. So that's called as linear regression. And why linear regression? Because you are predicting. Linear regression can never classify, it can only give you regression, that it can give you a real number, because weight is a real number. 67.2 is a real number, 80, 70 is a real number.
So for linear regression model, only one variable will be there,
A
right?
linear regression could have tens of variables. So suppose I wanted to say
Okay.
weight of
But
a person from
it'll,
height, and let's say height, ethnicity, whether it's an Indian or whether it's an American, it will change. American with a height of 180 and Indian with a height of 180, they'll have a different weights. So even ethnicity could come. Another
okay.
variable could be possible. What is the ethnicity? Is it Indian? Is it American? Is it South Asian? No, no. Is it Chinese or is it African? Right. Another variable could be there here. The another variable could be female or male. I want to make it generic. Uh, so female male is also a variable, isn't it? One, right? If it is a female, what with the weight of this
Yeah, yeah.
height? So these data would be given. In fact, the tabular format will have the data, right? For female, ethnicity, and height. So three variables now. But then the point is, whatever you get, the w would be in that case. Let's try to create it if the variable is 3. So linear equation is not only one variable; they can be. So now, how many features are there? If we have height, ethnicity, and gender, how many variables are there now? How many features are there rather?
Total three then. Total three
Total three
features.
features. Perfect. Now we have three features, right? So now W is 1 second. Hello. Okay. Now W is nothing but it is it is A1 H plus A2 E plus A3 F. And my machine
Wait,
learning
linear regression model is
yeah,
so linear regression model is only for it's only comparing for two variables. It can be for more than two.
it can be for more than two variables. It can be n number of variables. It could be n number of
Fine.
variables. But you understand this whatever w we will get here would be something like this. On the height, it is point. It would be something like a point. Let's say I'm just creating one scene here. Point 3h. I'm just creating. Could be or 0.442 only. Let's say this is ethnicity, right? Depending on ethnicity is a variable, right? Okay, so what could it be the value of ethnicity be given here right now? So that becomes a problem. See, h is a real number, ethnicity is a category, right? It is a category, isn't it? It's a
Okay.
category,
Yeah.
whether you are a Chinese
Yeah.
or whether you are American or whether you are it depends on that, right? So what will be the linear equation for that, and then if it is a male or a female, what would be the value here, right? So that would be a bit higher topic which I'll be teaching you right now. With the height, it was directly correlated. With category, we convert it into a something else, right? And based on that, we do it with. How do I teach you right now? Okay, I'll teach you right now how exactly. So what happens is, let's say four categories were there. One is American, another is South, let's say Indian, okay, another is Chinese, and another is, let's say, African, AF, right? So now what we do
Yeah.
is,
Okay.
so what we do
Yeah.
is
Yeah.
now
Okay.
this one feature will become a four features.
Fine.
So now
Fine.
what will happen is it will become four features, and now W will be equal to will be A1 H plus A2. So now E will go off. I'll replace E with A American plus A3 Indian. So the features are increasing now. Okay. A4, you'll just appreciate how exactly that happens now. A4 C is nothing but your Chinese plus A5 what is it? African, right? Now, what is the gender? Female or male, right? That is a two category or not? It's a male or it is a female, right?
Yeah.
So I'll have A6,
Yes.
A6, A6 female plus A7 male. Now, if my data input was height, now height, my data input was height was 180, ethnicity was Indian, and gender was male. Try to understand that if this was my input, then this will cancel out because it's zero. A is zero in this case, right? Though my formula will
Yeah.
have A2 here, but A is zero in this case because it's not A. So this will cancel out automatically.
Okay,
This will
fine.
cancel out because that's 0. What is the value of when my features have only these things? It's not American. So the A is equal to 0. AF is equal to 0 and Chinese is equal to 0. Right? So it will
Yeah,
depend on
that's right.
I. So for I, there is certain variable. For American, probably the A2 would be higher because American, or for Indian, it might be higher because Indians have big tummy, right? Americans don't have tummy. For an American, or probably Americans have more muscles. We don't know. For an American with 180 height, what is the A2? We don't know,
Mhm.
right? Either A2 and A3. For an Indian, it is higher or lesser. We don't know. That depends on the data, right? Collection of data. But remember what is A1? For A1, let's say in this case was
Yeah,
0.42h, right? That is what we calculated. But
yeah, that's
A2
right.
would be some value, but in this case it will cancel it out. And then for female and male, certainly A6 and A7. A6 will be lower than A7 because females are lesser in weight, right? A6 would be lower or
Mhm.
not from A7?
Yeah, A6 would be
Yeah.
lower.
So the equation, so this is what it will learn at the end of it. So if you really see the features, could you see how complex it becomes? No, it doesn't become complex. Basically it is depending on the features,
Okay,
but the model will learn
okay.
this equation. This constants would be learned. So A1, A2, A3, A4, A5, A6.
So the advantage is that we don't have to, yeah. So advantage is we don't have to manually find it. The machine itself will be able to find it based on the
Yeah,
data set.
absolutely. The machine would be able to find it based on a data set. And think that if you were supposed to find it, how difficult it would have been. You would have taken an Excel sheet, God knows what all you would have done, right? It would have been a 10 days exercise and still it wouldn't be accurate. And some more data sets comes. What will you do? You again go to your Excel sheet and you start doing it, right? Those statistics, you take all the Indians, you take all the US guys, you take all African, Chinese, female, male separately, and then you come to arrive at the equation, right? Given as a as a student, I would have given you this problem. You would have used statistics. There's another mathematics there. So and then you would have come up with this equation. Okay, and then but then this equation
Yeah,
is not right. It is all depends on how much data you had. Some more data comes in, you again go and recalibrate it, right? But in the machine you just feed this data again, it trains itself and it changes the value of a1, a3, a4, a5, a6, a7 automatically.
yeah. Mhm.
I think I taught you very too much actually in terms of at what level you are but you are able to get it. uh,
Yeah. No, no. So the thing is, I'm still a bit confused on the linear regression model. How exactly you would classify, like, how you can identify the linear regression model? Like, what is the, so basically, like, how do you describe it?
how do you describe it, right? So okay, so let's keep it simple. What I did was, here I took some categorical variable. There were dependency with there. So what happens is, that would come usually, now it's like too much of for you to teach in such a short duration. It has to be taken in a phased wise, which I did not do that. So you'll have a difficulty, but still I will tell you. Consider you did not have a categorical variable. Okay, so you had only what is categorical variable? These are categorical. Ethnicity and gender is a categorical because it doesn't have a real number. They are called
Okay.
categorical variable, and these are called as quantitative variable. The one which has real numbers are called quantitative variables. Okay, so let us.
Fine. And then the qualitative variable will be the
Yeah, so these
classification,
are
right?
called
Based on the.
qualitative. So this the categorical variables are also called as qualitative. So E is ethnicity is called qualitative variables. Gender is also qualitative variable because they don't have real numbers. Qualitative.
Okay. So for linear regression model is used for
So the
quantitative
linear
data.
regression model is used for quantitative prediction of only quantitative variables. It cannot do anything else.
Okay.
Well, but then the variables could be qualitative, but then you'll have to convert it into a quantitative variable.
Fine. Fine. So even if the variable is qualitative, it will convert into quantitative.
Quantitative, and that's what we did, right? So American, we created another variable called American. We created another variable called Indian. So we took out ethnicity altogether. We removed the ethnicity and we converted that into American, Indian, Chinese, and African, right? So now, whatever data set I have, either the person is Indian or American, right? So that variable, that feature, would get eliminated, because if he's an Indian, then American is zero, African is zero, Chinese is zero, right? So that's why I don't want to. Yeah, if you're
Yes.
able to understand, appreciate it. That's good. So that becomes zero automatically. So they will not give any. So that will become zero automatically. And if it is gender, male and female comes in as a variable, new variable, female is taken out. The gender is taken out as a variable totally. So you replace it. So now, after,
Okay,
though
fine.
we had, when we started off, we started with one quantitative variable and one qualitative, the two qualitative variables. But so we thought we had three variables. No, we what we ended up is, we took this as it is. This we converted into four, and this we converted into two. So totally, how many variables we ended up having? Seven. You got it. So now
Fine.
W depends on seven variables, seven
Got
features.
it.
And
Okay.
linear regression, so this was bit on the higher side, but then we should go systematically. Let us say, can you say weight of a person depending on two real numbers? Let's say height is one of them. What else could be there? Height.
The weight, age also
Weight
maybe.
depends on height and something real. Height is one of them. What else human being has a feature? Okay.
Height,
Age,
age, and
age. Very good, very good. See, age.
mhm.
Now it is going to work out. Right. Age is a real number. Okay. Age. Yes. So now my W would be a function of A1 H plus A2 A. So this would come something like point, whatever number, 0.42 H. As the age increases, as the age increases, so this as the age increases, it increases, right? So this will be something like 1.3 into A, right? Something like that will have.
Yeah.
Okay. So this is my W. So as the age increases, your so it's not proper linear. It increases. So as a person with the age of two would be lesser, but a person with the age of four, so 1.3 times four and 1.3 times two is lesser, right? 1.3 times two will give you 2.6, and 1.3 times four would give you 4 point, no, 5.2, right? And a person with age
Yeah, that's
a
right.
person with age 10 would give you 10 into 1.3 is 13. So as the age is lesser, the lesser number it contribute lesser to the weight. And this is your linear regression model for two features.
Fine. So WA1H plus A2A and then W.4. So when you're creating the model and the like so when the model will be created by the machine the machine only, right, based on the data given. So when you're doing that, you also have to check, then you have to also assess the model while the machine after the machine will develop it.
No, you have to choose. You have to tell which model to use. So there are various types of models.
Which model? Okay,
Exactly, and that's what
fine.
it was coming to.
But
Yes.
yeah, but the machine only will find the model, right, based on the data
No,
given.
you have to choose it.
Oh, no, no, the machine will find, but we have to choose, right? Or
We have to.
I thought because the machine will find the relationship. That's why.
This would be found by machine. A1 and A2 would be found by machine, but then you will have to say whether it is a linear regression or not. You have to say the model is linear regression.
Okay,
Linear regression model you have to tell, because there are different various types of models. Linear regression is one of them. There's something called as logistic regression, decision tree. These are all machine learning right now. Then you have decision tree, and then you have something called as there are what is it, SVM, support vector machine. We'll come to that. But apart from that, deep learning is all about neural network. So that is a different science altogether, and this is a different thing altogether, machine learning. So machine learning, you see the features are very clearly defined, but then if you really see neural network also, if you would have given, it would have also come to the same formula. Same
Fine.
combo.
So basically, so the machine will basically the machine will identify the relationships. We have to choose the models and check what type of model it is based on the relationships,
Based on the data.
based on the data. Sorry, yeah.
So if you use linear regression for your image, forget it. It can never work out. It will never work.
Fine. So it's based on.
The data,
So,
what
so
data you have. So golden rule is all difficult data like which is the data. We will come to data. Different types of data are there. Usually, the golden rule is any data which is difficult to understand. I mean, which is difficult to categorize in a systematic way. That is deep learning should be used like images, sound, right? Or let's say Wikipedia, no, no, Twitter reviews. They are not structured data. There's something called structured data and unstructured data. Structured data, usually you are going to use machine learning. Unstructured data, you are going to use deep learning. Because structured data, you can extract the features, right? But unstructured data, you cannot extract the features. You just cannot. Image, image is unstructured data.
okay,
What is structured data? Structured data is something like this. That this is my height. This is my age, and this is my weight. It's structured. Look at the structure. It is given 180.
okay,
180 plus age is 21. The weight is going to be something, right? So if it is 150 and age is 16, what is weight, right? So this is structured. Very tabular format, right?
So for example, for example, for image classification and image classification and training of the we can't use we can't use machine learning. We have to use deep learning for that.
We have to use deep learning. There are combinations of machine learning plus deep learning which gives you better results. There are certain models in machine learning which are good for doing it, but then there is something called as that is called ensemble. Ensemble means you use two or three models to achieve it. So you will have a model from machine learning which could be a support vector machine which is very good, or a decision tree plus a deep learning model which is nothing but a neural network. As I told you, neural network is nothing but yeah.
Okay,
And then
fine.
you combine these two to get better results. And there are various combinations of that to get good results. Basically, uh, the parallel to that is, let's say you want to create a bus from a basic engine. You could take from a Ashok Leyland. You will see a luxury bus. You will see a normal bus. You will see a AC bus. You will see a very substandard bus. Right? It depends on what materials you use. Right? So similarly, you have different types of model. You can attach different types of model to get you better accuracies as well.
Fine. Okay.
I think Adiv, you are able to catch it very well, and I really like it. So this is the first model we teach usually in machine learning is a linear regression, and there's a lot of science behind it. But right now, I just want to tell you what are different types of models. Basically, that's why I got to you. And in fact, if you
Yeah, so linear regression model one. So regression model, this model is what I understood is that it's used for quantitative data and prediction of quantitative variables, and then based on the various relations we get, we can combine them to create the other linear regression models. Like for instance, the one H and A2A and all. We can combine them to create the other relationships, and even for qualitative data, we have to convert into quantitative data to check the relationship when we're making a linear regression model.
very good, super,
Fine.
really good. And the crux of the machine learning deep learning is this equation. So when we talk about any model, right, you will have features. So now come to the point that now here the features was h height and the age. Coming to image, can you imagine what is the features in image? What are the features in?
Features for image will be yeah, will be a lot quite a few, based on height and based on pixels and based on color scheme and a lot of different variables will be there.
Perfect. So I will tell you,
Mhm.
you're right. Now let's come to it's not that way. It's like this. Let's say I have a image of I, and let's say we talk about pixel. Image is always talked in pixel. So let's say we had a 20, uh, 20, and this 30, 20 and 30 pixel. Okay. So number of features in this is nothing but 20 into 30. Number of features are 20 into 30, which is equivalent to 600. 600 features are there.
Fine. Okay, fine.
Why? Because every pixel, every pixel what we are seeing here, right? Just goes on like this, okay? And I'll
Yeah,
tell
yeah,
you how
totally.
exactly the pixels are stored also internally, because and then I'll give you one good example of for you to understand how machine actually sees the pixels and how exactly it learns from it. That example I'll give you next class tomorrow. So now you have 600
Sure.
pixels are there, right? So now 600 pixels take different values, as you said, rightly said. It could be what color it is, what brightness. So well, color itself gives you the brightness and everything. So it's like basically pixel is having the color. This is it. Pixel has only color differentiation 2 to 0 to 255.
Okay, yeah, fine. I think the RGB there is there, right?
Wow,
Based on that.
perfect. RGB. So every image actually has, every pixel has RGB. Three different values for R, G, and B, and they move from 0 to 255. When you combine them, you get a color out there. Now, the pattern, how the machine looks at the pattern inside it, and that is every pixel is a every pixel is a every pixel is a feature. And then tomorrow I'll tell you how exactly it distinguishes or it recognizes patterns inside the set of pixels, because you have 600 features, right? From this 600 features, different images will have different patterns based on the different values of pixels, right? And it becomes very complex for a
Right, right.
linear regression to do it. Come on, linear regression with 600 features, A1, you have to find A1 to A600.
That'd be too complex, and yeah, that probably won't. It'll not. It'll be very difficult to use the linear regression model for that.
Yeah. So I think either of you let me know. So this was, I mean, today's class. Like, did you understand things as you told you
Yes,
understand?
yes. I understood, sir. But maybe yeah, this pixel stuff we can go. We can go over in the next class also, right? When we're talking about image classification and all that.
Yeah. So
Okay.
so because you are doing on computer vision, we'll have to look into it, and slowly we'll have to see all the libraries which are used for computer vision. But then so I wanted to the point was, the biggest thing was to tell you about what model is, and you understood what model is basically.
Okay.
So let's see this. What happens here is feature extraction is a part in machine learning, and classification happens. So here, this is a just a classification problem. Machine learning, you can do classification as a regression. Here, you're giving input as car, and it has to classify whether it is a car or not a car. And here it says it's a car, basically, right? So you extracted the features. So image was given. It's not that in machine learning you cannot play with images. I told you linear regression cannot be used, but there are other models which could be used for with the images. Okay.
Okay. Fine.
And then you are telling whether it's a car or not a car. Uh, we'll have to see what are the models which are used for classification and what are the models which are used for regression. So linear regression is used for regression. So in any case, you cannot use linear regression for finding whether it's a car or not a car. You'll have to use different type of a model which is called as logistic regression. I'll tell you what logistic regression is afterwards. Though the name is regression, but then still it is used only for classification.
Okay. Fine.
And decision tree is used for classification, as well as support vector machine is also used for classification. And the same thing goes with deep learning. You can use it either way. You can use for regression, or you can use it for classification. So but here what happens is you just give the input, you don't touch anything, like what you did yesterday last class. You do not do anything, you just give the photos, that's it. And it was a deep learning model. It did the feature extraction, it did the classification automatically, based on which here it is telling car or not a car. In your case, it was Adif, mobile, and the background. So I think Adif, this is it. We'll do tomorrow then.
Yeah. Yeah. Sure, sir. Okay.
So we did not look at your image data set, right? So I'll just let's try to. Can you send me the link? Let's try to get the data and see.
Yeah. Okay. Fine, sir. I'll send you that link.
Okay.
I haven't downloaded it yet though. It was asking me to create a thing sign in, and I didn't do that yet. I'll send it now.
Okay, and then I will download the data and I will look into it. Tomorrow we'll look at the data as well.
Okay, but so it'll be I think images for the disease of iron also might be a little bit. I'm not sure how it will be. So then it'll
Exactly. So the part this part we'll have to do data preparation, right? So we'll have to see the data. We'll have to look into the data, ingest the data, classify by transform, right? So now we are at transform. We'll have to analyze and transform. So we have to analyze
okay.
the data now.
Yeah, fine. I'm sending it. Yeah, to you.
Okay. You're sending me now, or you will send me through mail?
Yeah, I'm sending it through mails. Oh, okay. I can send on the chat also, right? So, yeah, I'll send on the chat. I'll open the link. Yeah, I sent it. So it's on the chat for Google Meet.
Okay. So are they when are they going to teach you probability?
Probability. So actually, in term like in math, we've done basics of probability. Nothing like yeah, we've done basics, and then also a little bit we did in last year and also a little bit this year also. Not much. Just the basic, like based on these many people, like what is the chance for this and all. I don't think we've done it in detail. We also like for for multiplying probabilities to check the probability for many different conditions and all. We've also learned
Okay, great. And then did you learn vectors and matrices?
vectors and math. No, but I think we'll be learning about. I think I saw in the syllabus they've actually given us for next year. I think I saw that.
It's
I
there.
think they should be doing that. Yeah, yeah.
And
The
what about calculus anyway? They're going to teach you in 11th, right? So what happens? The whole machine learning, deep learning works on probability.
okay. Yes, so vectors and for vectors and vector spaces, right?
Yeah.
And yeah, and dot product also. Yeah, yeah. That is pending syllabus. They'll be covering that once school starts again. So for the next term.
That was in ninth class. They had this vector and vector space.
No, ninth, no. In see now ninth is over for us. Once we go to tenth, see school is actually opening a little early for us, July 15th, I think, but it'll still be online classes though.
Okay, so vector space is there, right? So vector space and matrices becomes a very important point here, and probability is the crux of it. So it also have you done combinations and arrangements and permutation combinations? Uh,
Yeah, I think I got disconnected.
Yeah,
Yeah.
yeah. So have you done permutation combinations?
No, so I know, no, we've not done the permutation combination. We've not done yet. Probably we'll be doing that from tenth, maybe.
Okay, so these are the because permutation combination goes with probability.
Okay.
Vector space matrices are the very important point. Why? Because whatever features we are talking about, they are stored as a vectors, and then you will see vectors are such an important tool. The whole of relativity theory was based on vectors and matrices. The Einstein
Mm-hmm.
theory, if you know about it, right?
Mm-hmm. Mm-hmm.
Anything in this world can be represented as vector. So vector becomes a very important point here because all the features when you talk about they become through vectors you can do amazing sort of things, searches and a lot of things, right? And probability is the crux of it and whole of machine learning, deep learning.
Okay, fine, sir. Sure, sir. Okay, so I think
Oh,
yeah, we'll look at that next class probably, right?
yeah, yeah. Right.
Okay, thanks, sir.
Okay. Bye.
Fine. Bye, sir. Bye.